This project I'm involved in particular, is about research for a very elusive type of asteroid, which I call Trojans. And for researching this asteroid, we asked to an help to the Saverio mission. I'm sure that most of you heard about that. And in particular, the project is led by the PI of the mission, which is Dante Lavetta, and my advisor at LPL, Renu Mahor. We got also help from all the team, the Saverio team, and the Catalina Space Service. Alright, so we're gonna talk about asteroids. What is really an asteroid? When I googled that, the first definition was that an asteroid is an echinoderm of the class Asteroids, a starfish. And I started like wondering about like a starfish traveling around like the sun. Okay, yeah, that's pretty cool. I mean, like, alright, I want to talk about what an asteroid really is. An asteroid is a rocky body orbiting the sun. When all the planets formed, not all the material that was in the modern history was used for forming the planets. There are some leftover of this planetary formation, and they form the asteroids. So asteroids can range from very big ice to dust level, and the nice point of asteroids, which is maybe the core of my talk tonight, is the fact that asteroids didn't change so much from when they formed. So they are like a sort of time capsule, and we can say like that asteroids stay to planetary science as fossils stay to paleontology. And so why we care really about asteroids in planetary science? First of all, because as I said before, they can say a lot regarding the origins of the solar system. Moreover, there are a lot of theories about the possibility that life has been carried on by bombardment of asteroids and comets on Earth. And so we would like to go there and see if there are these precursor molecules for life. Moreover, there are today a lot of companies would say, especially here in the United States, that we want to go on asteroids and mine these asteroids, because asteroids are very rich in metals, and some type of metals are becoming like more and more expensive to be extracted on Earth. Moreover, NASA, this is another important point, some of these asteroids are dangerous in the sense that they have a different from zero, I would say, probability of impacting with Earth. And NASA would like to send astronauts on asteroids to train them, and so it's like a sort of gym for them. And I would add 6 points that they are very cool, and that's why I'm doing research on them. Alright, yeah, so asteroids seems all equal, but there are some asteroids are more equal than others, as I always would say. And in particular, one of that have been selected as the target for the Saverio mission, which is them. So, from this big pool of 500,000 asteroids, the mission team narrowed down to a group which are called near-Earth asteroids, which means that they are pretty close to Earth and pretty easy to reach with our spacecraft. But since the Saverio mission has a goal, the primary goal is go there, take a sample and go back, these asteroids should be in an orbit that should be easy to provide the spacecraft with condition of come back to Earth. Then here, like a concept like from an engineering perspective stopped, and then the science started to play a role. Indeed, some asteroids are very small, and they are tumbling in space. And if their rate of rotation on itself, the spinning, is very fast, they're gonna eject the material on the surface. And this material is what we would like to sample, so it's better that they don't eject this material. And so the team decided for asteroids that they should be bigger than a certain limit, which is 100 meters in diameter. Moreover, the most primitive asteroid, so the most interesting asteroid from a solar system history point of view, are carbon-rich asteroids. And then the winner have been Bennu. Alright, I will show you. Okay, so Venno, like, is the target of the mission. Doing a little, I'm going a little bit out of topic, but just to contextualize what we know and what we don't know about asteroids. Even if this is the target of a NASA mission, so you should say, okay, yeah, it's the target, so we should know it's pretty good. I mean, like if we will do a mission to Mars, we know Mars where it is. And the problem with that is that we don't know a lot. We don't know the shape. As you can see here at the uncertainty, the shape is not negligible. We don't know what material is composing it. We don't know how much light is reflected from the surface of Venus, which is a proxy for understanding the physical composition. And moreover, we don't know the orbit very well. And these are guides an hazardous asteroid, so it can impact Earth with a finite probability of impact. Alright, here is my first trigger question for you. I would like to list these three objects, so the bell tower, Venno, and the Empire State Building, in order of decreasing size. Right? Yeah, it seems great. Very good. Yeah, so here are the three object scales, and as you can see, it seems from a human perspective that this object is pretty big, but really it's very hard to target this type of object. If you want to target, like again, Mars or Jupiter, they're pretty big, and their orbit is well defined. But this object is not well defined in its orbit, so it's very an engineering challenge. Alright, going back to Trojan, I think so the launch of this probe in 2016. The PI is very happy because it's been a perfect launch. And this is like the scheme of the mission. So we have a launch 2016, cruise, then the mission will go around a little bit the asteroid mapping for understanding what should be the best site for the selection. Then there will be the sampling very fast going back to Earth. The story that I would like to share with you tonight started in the middle of the cruise, and in particular when Asteroids happened to be close to a very peculiar point in the solar system. In particular was February 9, 2017, and Asteroids approached a point called the Earth-Sun L4, and here they search for these Earth Trojans again. So, for explaining what the L4 is, I would like the help of two colleagues of mine from LPL. I would like thank you for coming. They volunteered for that. And in particular, this Lagrangian point, which in particular we are interested in these two, L5 and L4, are points in the solar system in which, if I put a mass there, with respect to the Sun and Earth, the mass will never move. And I would like to demonstrate it with my... Alright. So consider that this is the pool, I am the Sun. Okay, I'm pretty flat. Alright, so I'm the Sun, and this is the gravity pool of the Sun and the Lagrangian point, which is the Lagrangian point. This is the pool of the gravity pool of Earth, the Sun to Earth. And you can see that the Earth is actually wobbly because it's a little bit round. So then the Earth is exerting a force over the Lagrangian point. If this guy moves around, like these points will remain always in this configuration, which geometrically is the equilateral triangle. Right, yeah, that would be the easiest way I figured out to explain it, sorry. Dynamically, it's not really a trivial point. Anyway, if you believe me that if you put something like a spacecraft or an asteroid there, it will remain stay there forever. We can also see that like really is not a point, a precise point. Of course, it's a physics concept, so it's not defined as a geometry, perfect geometry. But you can have stable orbits around these points. In particular, these parts will move around the Sun as any other object. But in this particular system, they will orbit at 4. And in particular, they can do that because this is a stable point. It's the concept like of the pendulum. I mean, like when you have a pendulum like that, this is a stable point for the pendulum because it will stop in this way. But if you have a point like that, which is the 1 and 3 and 1 and 2, if you apply a small force in this position, the pendulum will go down. And it's the same with asteroids. Alright, so what's a Trojan asteroid? We define Trojan asteroids as the asteroid that stays in L4 or L5, which is the heat symmetric point since the system is symmetric. And in particular, we know that many planets like Jupiter, even Mars, they have Trojans. But we are interested in Earth Trojan, and so far we know only one declared Earth Trojan, which is 2010 TK7. But there are some debates if it's a Trojan or not. For instance, regarding Jupiter, here you can see Jupiter, here is the Sun, here is the orbit of Jupiter, and these green dots are the Jupiter Trojans. Technically, they would be called Trojan and Greeks, so they front one each other. It's like pretty cool. So, as you can see, these guys are sharing the orbit of Jupiter, and they are staying always in the same configuration with respect to the Sun and Jupiter. So, if you have been very quick to count all these green dots, I would like to propose you my second trivia question. All right. So, what is the number of Jupiter Trojans that are estimated to share the orbit of Jupiter? So, it's estimated in the sense that we didn't detect yet all these stars. No, it's too low. It's a B? No, it's too low. C is correct. Okay, we say C. Okay, these have been a little bit surprised. I got a bit surprised about that because, this is the same amount, same number of asteroids that you could find in the main belt, which is the belt between the orbit of Mars and Jupiter. And so this is an estimated number. I think they just computed by models, of course. But it's pretty amazing. I mean, Jupiter, since it's very big, it can retain a lot of asteroids. But what about Earth? Why we are interested about Earth Trojan? If you remember what I said at the beginning of the presentation, asteroids are the building blocks, the remnants of the formation of the planets. So, since these Earth Trojans are pretty close to Earth, they are likely to be remnants of the building blocks of Earth, of our planet. So it's pretty interesting. Moreover, if they get destabilized, so I told you before that these guys will remain there quite forever. But if a great perturbation from the Sun or a collision occur, they can get destabilized. It's quite rare what can happen. And if they get destabilized, they can easily go to Earth and collide with Earth. So it's better to know this population a little bit better. And I think the motivation that convinced the Saverio team to make us using their camera is the fact that have been a good testing bench for the onboard cameras to observe from the spacecraft, from that particular position, these objects. So maybe you could ask, since these are so dangerous, so interesting, and all the kind of stuff, why we are not observing them from Earth? Because usually we observe asteroids better from Earth. The fact is that if you think about the configuration, and I will not call again my colleagues that are safe for now, the observation of this asteroid is possible only at dawn of sunrise and sunset, which it makes the observation of that a sort of nightmare. But scientists think that there are some evidences that these asteroids are there. And one of the most important evidence came from the Moon. So our closest neighbor is expected, as the Moon is orbiting Earth, but Earth is orbiting also the Sun. the leading edge and trailing edge, so let's say one hemisphere and the other hemisphere of Moon, are expected to present a difference in the number of craters that you can find on the surface. In particular, it's like running in the rain. The number of drops that will hit your forehead will be less than the one, more than the one that you that hit your back. And so this is expected. All right. But the scientists proved that the number of this discrepancy, this difference, is even larger than expected. And this difference could be due to an unseen population of impactors, so asteroids that bombarded the Moon in a recent past. And in particular, they could be our air Trojan. So there are some evidences for searching now. Regarding the images, we take them using the onboard camera of Osiris-Rex, which is Occam's. Occam's really like Osiris-Rex because they have all these images that it seems like, I don't know, a god that appears and so on. Anyway, this Occam's is composed by 3 cameras. The camera that we used, the cameras are MapCam, SatCam, and BodyCam. The camera that we used is MapCam. And why is that? Because this camera is thought to look for natural satellites around Venus, which is like looking for very tiny and faint objects in a dark background. So it's more or less what we would like to do. Because remember, our observation of the Trojan is from inside more or less this cloud that we expect is there. Regarding the observation details, this is like the angle of the plane of the orbit of Earth around Sun. This is the angle in the orthogonal perpendicular direction. And it's pretty big as a survey because the camera has a quite good field of view. And we observed from opposition, which means that the Sun was behind us, behind the Osiris-Rex. The observation that we did were between February 9th and February 20th, and in particular we checked for the moving objects, first blinking, manually blinking, which means that if you can see here, these are 2 images that are scrolled. The stars stay in the background fixed, of course, because from our perspective the stars are fixed. But these objects are moving, and if you scroll, you can easily see them, but it's not always so easy to see them. And in particular, we also used a software, detection software by the Catalina Sky Survey. Alright, so very long introduction to these guys. Are you ready for the results? Hello. Alright, so first of all, we detected 17 asteroids. Oh yeah, so full of Trojans, they're gonna bombard the Earth, we're gonna die. No, these are 17 main belt asteroids that we knew that they were there, and so we detected them. Moreover, we detected also a planet and 4 moons. I say, wow, yeah, I feel like Galileo. Okay, yeah, but really it's a very well-known planet, is Jupiter. And we detected that it's 4 Galilean satellites, like they are the biggest. Regarding what I was saying before about the blinking, this is if you can see here, there is this big guy which is called Victoria, and you can easily see him in the background, even if there is a lot of noise, and we'll comment on that later. Alright, so I don't know if to say I'm sorry or not, because it's not like science works, but really for now, as the first round of image processing, we didn't detect any Earth Trojan. And if you were wondering, the one 2010 PK7 was in the field of view. I checked it, I'm pretty sure. But was too faint to be detected. We found a very strange type of noise, which is called random telegraph noise. They're making the stuff a little bit more complicated, in the sense that the pixels in the camera are like switched on and switched off randomly, which means that you cannot map them very easily. We can do something, but it's hard. Alright, so let's take for a moment to this first preliminary, I would underline preliminary. results. So, what means that there are no Trojans? Okay, first of all, maybe we didn't detect any Trojan. Okay, first of all, I would like to say that even if we didn't detect any Trojan, this doesn't mean that there are not Trojan, because our camera has a limited capability, of course. And first of all, the first limit, very important, is that we investigated the small fraction of all the space that these Earth Trojan could, or including which they could orbit. And if you remember some slides before, they can be stable around in a pretty large area. So we investigated a small one, because the field of view seemed pretty large, but was large from the perspective of the spacecraft, not from the point of view of the Sun. And moreover, the Lagrangian system, like the system with the Earth, the Sun, and this point, is like a sort of idealized system, because we are not considering any other type of force. Is approaching. Yeah, so we have to consider it like that other forces are working on these asteroids. First of all, the Sun, because since this is a condition in which you have very few perturbation, let's say, because it's stable and all the gravity is well balanced in a certain way. It's not the perfect way to say that, right? We have if there is some solar radiation pressure, it can exert a quite significant force. And we are pretty close to the Sun, since the orbit of Earth is closer than that of Jupiter. And moreover, we could have seen some collision between them. And collision reduces the size of this object. And if you reduce the size, you're gonna affect the possibility that we could have been detected. Alright, so but we don't give up. We are processing the image again, and we are working for improving the quality of the images. First of all, cleaning for all the noise, then stacking the images, and we have some star image processing guy that is working for us. In particular, image stacking means that you are going to take some pics of the same location at the same time, at very short distance in time, and you're going to superimpose them. And this can allow to remove some common feature or improve the quality of the image. So we are right now we are processing these images, and they are very interesting results. Unfortunately, I'm not supposed to deliver right now, but I'm very excited, and you should be, because it's very clear. And anyway, it's gonna be great, and so stay tuned for that. And a very nice point that I really like it, and I've been surprised when I went to my brother and say, oh, we didn't find any Trojan. And so, yeah, but we can really find a lot of information from zero detections. And in particular, we've been able to characterize the Catalina Sky Survey efficiency pipeline, or the efficiency of the pipeline, sorry. Because we knew from the NASA archive what asteroid, named that asteroid, should have been in that in the field of view of the camera. But we didn't detect all of them, which means that our efficiency is not 100%. And this is very important, because we use this result for setting an upper limit of the population of Trojans that could have escaped detection at the limiting magnitude. The magnitude is like an indicator of how much light is reflected from the asteroid. So this is very useful to characterize the population, because from this experiment, we cannot say that there are no Trojans, but we only can say that there are no Trojans from a certain size in that particular point, maybe. I'm not sure about it, but we cannot do the other stuff. Alright, so I would like to invite you to join the Asteroids mission. There are a lot of social stuff that I'm using, like few of them, very a lot. And they are gonna, the spacecraft is coming back to Earth, not because it has already the sample, but because it's making a gravity assist to get a gravity kick from the Earth and going to Venus. So it's they're very like hectic days for the team. So they need support. So with that, so that's everything from L4. I would like to thank you for your attention, and if you have any questions, I'm here for this.